Section 2.1, Prime Numbers and Divisibility. In this section, we will start by talking about the factors of different numbers. Factors are numbers you multiply to get a particular product. So, for instance, the factors of 10. What numbers can you multiply together to get 10? Well, 1 times 10 or 2 times 5. So we could create a list, and oftentimes you will see it written that way. We could create a list of the factors of 10, and it would be 1, 2, 5, and 10. How about the factors of 12? Well, the factors of 12, the numbers you multiply to get 12, 1 times 12, 2 times 6, 3 times 4. And usually the factors are written in order from the smallest number to the greatest number. I'm not going to do that right now, but we certainly could go through and do that. Given the factors of 24, what are the numbers you can multiply together to get 24? Well, there's a few more. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So one aspect of this particular section is just figuring out the factors of all those different numbers. Just one thing to remember, I gave you the whole number factors of these. Let's go back to 10 for a minute. We had said that the factors of 10 are 1, 2, 5, and 10, and those are the whole number factors. And in this particular class, that's all we are looking for. I just want you to realize that there are other numbers you can multiply together to get 10. For instance, I could, if I wanted to, multiply 1/2 times 20. 1/2 times 20 would also give me 10. But we will not be talking about those factors. We are only talking about the whole number factors. Let's talk about finding the factors of one more number, and that number is 17. What are the factors of 17? Well, as you look at it, there are only two factors for the number 17, and that is 1 times 17. There are no other whole numbers that you can multiply together to get 17. So there's a name for this particular type of number, and the name is a prime number. Prime numbers are numbers that have exactly two factors. And there are a lot of prime numbers that it would be good if you were able to come up with a list of them and start to commit them to memory. There are actually 25 prime numbers between 1 and 100, and we will be talking about that, or we have talked about that already in class. If numbers are not prime, we call them composite. Composite numbers have more than two factors. So earlier we had talked about the factors of 10 being 1 times 10, 2 times 5, has more than two factors because the factors are 1, 2, 5, and 10. So the number 10 is a composite number. One thing to remember, the number 1, the only factors of the number 1 are 1 times 1, or just 1. 1 is a whole number that is considered neither prime nor composite because it does not fit either one of the two definitions. Sometimes in math, it is important to be able to determine all the factors of a particular number, especially when working with fractions. For that reason, it is helpful to understand what is known as divisibility rules. I am sure you already know some of the divisibility rules, but let's summarize them now. Is 2 a factor of the number 84? Yes, it is, and you probably know that because 84 is an even number. 2 times 42 equals 84. Knowing that 2 is a factor of all even numbers is the divisibility rule of 2. Any number that is even has a factor of 2. Is 5 a factor of 95? You probably know it is. Once again, because of the divisibility rule of 5. Any number that has a 0 or 5 in the ones place has a factor of 5, which means it is divisible by 5. Finally, is 10 a factor of 74? No, it isn't. You probably know this because in order to be divisible by 10, a number has to have a 0 in the ones place, which is known as the divisibility rule of 10. Before continuing, I have made 3 different lists here, and you can see that I have 2, 5, and 10 above each one. Take a look at those lists and tell me which of the numbers underneath each list is divisible by the number above. You can just do this mentally or you can write them down. I will go over the answers very quickly. Okay, as far as the answers go, I'm going to circle the ones. As far as the very first list, which numbers are divisible by 2? Well, any numbers that are even. So that would be 592, 600, and that would be it. Just those 2 are even numbers because in the ones place ends in 0, 2, 4, 6, or 8. As far as the second list, which numbers are divisible by 5? Well, in order to be divisible by 5, the number in ones place has to be a 0 or 5. So that would be 160, 14,235, and 640. In the final list, which numbers are divisible by 10? In order to be divisible by 10, a number has to have a 0 in the ones place. So that would just be 2,370 and 90. These 3 rules for divisibility of 2, 5, and 10 are fairly easy rules, but there are other divisibility rules that we'll talk about next that are not quite so common. As far as the divisibility rule of 3, I have created 2 lists here, and I will tell you that the numbers to the left are divisible by 3, and the numbers to the right are not divisible by 3. Take a moment and see if you can figure out what's common with the numbers to the left. As you take a look at the numbers to the left, you might notice that if you add each of the digits together, that you are going to have a multiple of 3. So if I add up 1 plus 0 plus 2, I get 3, and 3 is a multiple of 3. If I add up 3 plus 5 plus 1, I get 9. And 9 is a multiple of 3, or it's divisible by 3. If I add up 6 plus 7 plus 5, I get 18. And once again, 18 is a multiple of 3, or we could say 18 is divisible by 3. On the right-hand side, if I add up the digits, 5 plus 2 gives me 7. 7 is not divisible by 3. 4 plus 3 plus 1 gives me 8, and 8 is not divisible by 3. And 7 plus 7 plus 5 gives me 19. 19 is not divisible by 3. So, in order to be divisible by 3, the sum of the digits in the number have to be divisible by 3. Let's do a similar exercise for the divisibility rule of 4. The numbers to the left are divisible by 4. The numbers to the right are not. Take a moment once again and see if you can find common characteristics of the numbers in the left column. When you take a look at the numbers in the left column, and you take a look at the number formed by the tens and ones digit, you will notice that that number is divisible by 4 in every one of those cases. 32 divided by 4 gives me 8. 12 divided by 4 gives me 3. 20 divided by 4 gives me 5. So, when I take a look at the number, I'm not adding the digits or anything, I'm just taking a look at it as a number. The number that's formed by the tens and ones digit is divisible by 4. When I take a look at the numbers in the right-hand column, 14 is not divisible by 4. 22 is not divisible by 4. 18 is not divisible by 4. So, those numbers are not divisible by 4. In order for a number to be divisible by 4, the digits in the tens and ones column that form a number have to be divisible by 4. Take a look at these two columns for the divisibility rule of 6. And once again, do you see anything that's common with the ones to the left and not the ones to the right? First of all, notice that the ones to the left are all even numbers. So, in order to be divisible by 6, one thing that has to be true is that the numbers have to be even. The other thing that has to be true is it goes back to the divisibility rule of 3. If I add up these digits, 1 plus 0 plus 2, I get 3. And 3 is divisible by 3. If I add up 3 plus 9 plus 6, I get 18. 18 is divisible by 3. If I add up 4 plus 0 plus 8, I get 12. And 12 is divisible by 3. In order to be divisible by 6, the number has to be divisible by both 2, so it has to be even, and 3. And if you think about it, that makes sense, because 2 times 3 is equal to 6. When we take a look at the ones to the right, notice that the first two numbers, 712, 452, those are even numbers. But if I go through and add up the digits, 7 plus 1 plus 2, I get 10. 10 is not divisible by 3. If I add up 4 plus 5 plus 2, I get 11. 11 is not divisible by 3. When I add up 3 plus 0 plus 3, I do get 6, and 6 is divisible by 3. However, the number 303 is not even, so it's not divisible by 2. So, in order for a number to be divisible by 6, the number has to be divisible by both 2 and 3. The last divisibility rule we will look at is the divisibility rule of 9. So take a look at the three numbers to the left again and see if you can see any common characteristics. As you take a look at those three numbers, the numbers that are in there are, once again, when you add up the digits, you get something that is divisible by 9. It is very similar to the rule for 3. 7 plus 1 plus 1 is equal to 9, and 9 is divisible by 9. 5 plus 0 plus 4 is equal to 9, and 9 is divisible by 9. 7 plus 7 plus 4 gives me 18, and 18 is divisible by 9. When I look at the ones to the right, 8 plus 2 plus 1 gives me 11. 11 is not divisible by 9. 5 plus 6 plus 6 gives me 17. 17 is not divisible by 9. 4 plus 0 plus 6 gives me 10, and 10 is not divisible by 9. So, the rule for 9 is very similar to the rule for 3. In order for a number to be divisible by 9, the sum of the digits has to be divisible by 9. Here's a list of all the divisibility rules. I'm not going to read them aloud, but it might be important for you to copy these down, and you do need to know these as we continue to go through this class. Notice that there are no divisibility rules listed here for 7 or 8. There are divisibility rules for 7 and 8, but they are so cumbersome that it's really easier to just see if the number 7 or the number 8 is a factor of a particular number by just going through and dividing. If you have any questions on anything with this particular section, please let me know.